Good morning, students. Welcome to the lecture series. In the previous lectures, we have already discussed about the microsensor, and two types of microsensor have already been discussed. In this slide, we will discuss about another types of microsensors like chemical sensor, optical sensor, thermal sensor, and pressure sensor. So, in the previous lecture, we have discussed about the acoustic wave sensor and biosensor. Acoustic wave sensor was the sensor that sense chemical compound in any gas. But now we will discuss about the chemical sensor. What is chemical sensor? Chemical sensor is the sensor which senses any particular chemical compound in any type of alloy, you can say, any type of metal, you can say. So it works on the principle that many material are sensitive to chemical attack. Like if we take an example of oxidation, many metals, most of the metal are vulnerable to oxidation when they are exposed to light, to air or light for long time. So oxide layer that is built upon the metal surface can change the material property, and that material property is the electrical resistance. So the when a device is not exposed to the light, not exposed to the air, so at that electrical resistance is not equals to when it is exposed to the light. The difference of that electrical resistance make it visible, make it be done for a chemical sensor to work on. So on this principle, microchemical sensors are being designed and developed. So on summing up all these things, we will see that to sense any particular chemical compound, chemical sensor is used. Next we will talk about the optical sensor. Optical means light. So it works on the principle that the interaction between the photon in the light and electron in the solid that receive light. So in optical sensing devices are there like phototransistor, photodiodes, on which this on the surface of that the light is being absorbed. So so on that principle, optical sensor are being used. So that optical sensor is a device that convert optical signal into electrical output, and that electrical output is the input of any actuator. So optical signal is designed to sense the intensity of light. So in our daily life, we have seen phototransistor and photodiodes as a optical sensing device that are these. So in this photodiodes and phototransistors, the photon energy is being absorbed by this device, and that is being converted to an electrical signal. So this is all about the optical sensor. Next we will discuss about the pressure sensor. As you know that pressure sensor is, you can say, it is a mechanical sensor also. We are giving a mechanical pressure on any device, and after that the pressure is being sensed by any type of electrical device, and the output will be generated as a electrical signal. So there are generally two types of pressure sensor. First is absolute and gauge pressure sensor. Absolute and gauge are two different types in terms of the schematic of the design of the cavity. Like absolute pressure sensor, evacuated cavity on one side of diaphragm. Like on one side of diaphragm there is an evacuated cavity. The measure pressure is an absolute value with vacuum as a reference pressure. Means there will be vacuum in the evacuated cavity, and on respect of that, if we apply any pressure to that cavity, it is being observed. Next we will talk about the gauge pressure. So it doesn't require any evacuation. There are two types of ways where on the diaphragm we can apply the pressure, like with backside pressurization and with front side pressurization. This is the backside pressurization, on which this is the backside pressurization, and this is the front side pressurization. So with backside pressurization, there is no interference with signal transducer. Actually, the signal transducer is being planted on the top of the diaphragm. Okay, with backside pressurization, if we apply pressure on the backside, there will be no interference with the signal transducer. So it is a benefit of the backside pressurization, and mainly it is used means backside pressurization is normally used. With front side pressurization, as there will be interference, so under some special circumstances it is being used. So these are the types of, this is backside pressurization, this is front side pressurization. So this is, you can say ki, this is silicon die with the diaphragm, this is the base and the cavity, and this is not evacuated cavity. So backside pressurization, so यहाँ on this part we apply the pressure, and for with front side pressurization on this part we apply the pressure. Okay, so you can see that there is an interference with any type of signal transducer placed on the on this diaphragm. Yes, next we will talk about the thermal sensor. Thermal sensor, as you know, that what is thermal? Thermal is a heat, so it senses the heat, or you can say it senses any changes in the temperature. So to sense the change in temperature, thermocouples are mostly used. So they operate on the principle. How they are operated means there are basically they operate on the principle that the EMF produced an open end of two dissimilar metallic wires. Means there are two types of metals, different metal wires, and when the junction is heated of these wires, the EMF produced can be changed. So the dissimilarity of this EMF1 is not equals to EMF2. It senses that there is something heat is on that object. The temperature rise in the junction can be correlated to the magnitude of produced EMF. So there are two types of metals like this, metal wire 1, metal wire 2, and at the junction when it is heated, the EMF1 is not equals to EMF2. So this correlation makes the thermal sensor to sense the activity. Yes, this is all about today's lecture. So if we take a brief review of the lecture, we have discussed about the chemical sensor and pressure sensor, thermal sensor and optical sensor. First, when we have talked about a chemical sensor, it senses any particular compound in an alloy, in a metal or anything. Next we have discussed about the optical. It means it senses the optical, or you can say it senses the light and convert into the electrical signal. Next we discussed about the pressure sensor. So on applying pressure, the mechanical activity is being observed and that is converted to an electrical signal. Next we discuss about the thermal sensor. Thermal sensor, it senses the heat which is provided by the two different type of metals, and when EMF1 is not equals to EMF2, this activity is being sensed and it is converted to an electrical signal. So this is all about today's PPT. Next we will discuss about